Okay, this is working. That's good. And this is working. That's even better. Ohayo gozaimasu. Thank you for coming. I don't know why I have a bar on top of it. Oh yeah, now it's bigger. Now it's not. Good. Yeah. I'm Maciej Mensfeld. I'm a Ruby programmer, software architect, whatever you call it. Doesn't really matter, does it? I do open source, and I do it a lot. And you can find my code in many projects, not only the one that I'll talk about. You can find my code also in dry Ruby libraries, in Trailblazer, a couple other places. I work at Castle. Castle will be my proof of example on how using Kafka and Karafka can work efficiently. It took me 24 hours to get here, so I have a small jet lag. I live in Krakow. I had to go from Krakow to Warsaw, from Warsaw to Tokyo, and from Tokyo here. But it's fun, and I hope you had a nice experience traveling here as I did. I'm also an organizer of Krakow Ruby user group. That is one of the biggest local Ruby user groups in Europe. We have over 1,200 members, and we meet up on a monthly basis, always with 2 technical talks and a lot of beer. Feel free, you're invited always. We look like this. We meet with 100, 150 people. We'll be talking, beer, usual stuff for Ruby programmers. It's my first time at RubyKaigi, first time in Japan. I'm a Kyokushin karate practitioner, and I love Full Metal Alchemist. And funny fact, I actually own a tree in Japan. I took a contest, and I won a tree somewhere here. So in this place, in a forest, there is a tree with my plate on it, at least for the next 12 years. So it's super cool. This is my wife. And you can find me on GitHub. You can just mail me. I run a blog mostly about Ruby stuff and Kafka-related things. If you have any questions, here, or just mail me. I'm going to every single after party and party that is going to happen during RubyKaigi. So if you want to talk with me about virtually anything, yeah, just buy me a beer, get me a beer, and it's going to be fine, I promise. But mostly I do this stuff, and yeah, blah, blah, blah. I tend to get nervous, and I have a jet lag, so if I speak too fast, just throw something at me. If you have any questions, yeah, just ask. Usual. I hope you'll get something interesting out of my talk. I think it's interesting, so that's good. I'll go through some basics. I need to keep the time. I'll go through detail some small things about Kafka, how is and how was Kafka and Ruby for the past 5 years. What is Karafka? What is the mind shift behind of it? Because it's a bit different than doing typical Ruby on Rails stuff. But I get to this at some point, and a nice 1 or 2 use cases. So usual boring definitions just to remind us on event-driven architecture. So event-driven architecture is super simple. You just send events and you consume them. Done. Immutability. If you create something, just freeze it. Done. Domain-driven design. How can I explain it easily? I want Anton has a talk. I'm opening this room. Anton has a last talk today, so please go to his talk. He'll explain this better than I do, because he has some GIF animations. I don't. Event sourcing. Long story short, you create events and you don't remove them. Event sourcing, done. And one more complex thing that I really love about DDD and its sagas or process managers. And it's just a technique of tackling complex business transactions in a bit easier way. So you just spin up or build up. It's not a process, you don't spin it up. But you build up entities that are responsible for handling long-running transactions. And by transactions, I don't mean database transactions. I mean like business logic transactions. Simple example of event-driven shopping cart. So usually when people build, like, if I would go and ask you, build me a shopping website in Ruby on Rails, you would just build up a shopping cart, and you would have, let's say, books, and you would have items, and you would just increase the counter each time you add a new book, and it's the same book that you already have in the counter, you just add +1 to the quantity. And this is not how it works with event-driven design shopping cart. You just add events that something happened or that something changed, and you just materialize it if you need it. You need the current state of it. So you just squash it. You have the current representation of reality. But what you have behind is the overall picture, overall history of all of the things. Oh yeah. Go to Anton's talk if you want to learn more about that, because I will be talking more in a Ruby context, and in Kafka context, he will have a general introduction to more of the DDD stuff. Really nice guy. Drink with him as well, like with me, please. There are certain benefits to event-driven architecture. The first one is that it reflects reality. Even if I would ask someone from you, how are you? You wouldn't tell me I'm fine now, but you would tell me, yeah, I woke up, I had a huge jet lag, I didn't eat anything because I got stressed because I have a presentation, right? You get the whole picture. And the same happens with event-driven architecture. You get the whole picture. And the problem is that we don't build our software that way. I don't know why, but people tend to have this snapshot of reality as it is now. Not as it was, plus how it is now, but how it is now, and let's not care about history that much. Yeah, obviously we have some logs for, I don't know, production, we have some statistics on how the system is performing, but why don't we apply the same to our business logic? Truth be told, data is the new oil. And you may not be aware of future things you will be able to do with the data you have now, if you have it. If you don't have it, if you throw it away, you won't be able to do anything with it. And you may end up in a point where you would wish you would have it. So even if you don't use it, store it. Storage is cheap. Yeah, you can. Let's get back to our shopping cart example. If you would maintain only the current state, you wouldn't be able to ask yourself some questions that can be really useful when you start doing machine learning. You may be able to detect the correlation in between the products that people were willing to buy together, but they didn't for some reason. But you can always run a campaign and offer them other things if you have the knowledge. You can start asking yourself why it takes so much time for customers to buy something on my website, right? There must be a problem because they started the whole process 5 hours ago and they're finishing it now. So something is suspicious. You don't have this data, you just see a successful transaction. Hooray, someone bought something on your website, but maybe there could be like 5 times more customers buying. And yeah, just next question about it. Next benefit of event-driven architecture is that thanks to the approach, you don't have to communicate in between applications directly. And it's super useful because if you communicate directly, it just creates many problems, and you have to maintain things on both ends, and you're unable to shut it down for a second if you need, or an hour, or a day, or sometimes you just forget about an app for a week. Yeah, it happens. Thanks to immutability, it's great for performance. It's great for availability and scaling, because you can decompose your problems, your challenges. You can decompose your features and functionalities and replace them and maintain them separately. I know that microservices aren't always the best and long-lived, the huge monolith. But even within a monolith ecosystem, quite often you can extract really small functionalities, even one-way functionalities, that will provide you certain benefits without the overhead of having them in the main code base. The quality is much better. Believe me on that. If not, get me a beer after the talk, because I have a lot of slides. But there are downsides, and they're pretty serious. One of them is the asynchronicity, which makes debugging a bit harder. They aren't callbacks, but it still happens somewhere in the background. And if you have events that trigger other events, you might end up having a huge loop. So loops like that cause a lot of noise and trouble, and sometimes it's really problematic to track them down. Eventual consistency. This is a problem as well, because there are some systems that don't allow that. Majority of applications that I've built are fine with eventual consistency, but you need to keep in mind that if you're unable to do that, you're probably better without it, without the events, or at least you will be better with having a monolith app and having transactions. Kafka provides transactions, but it's still eventual consistency, and your data will be in an inconsistent state for some of the apps. For example, when you shut them down for a maintenance and put them back later on, their materialized view of current state of reality won't reflect what you have in other systems until you replay the whole data. Yeah, aggregation route, never mind. The problem with immutability and the fact that you don't remove data is that if you want to correct something, you will be required to generate more events. You can't just go into a database and patch something up. You need to have events to update the current state, because everything is about events. If you start playing with fixing database directly, you will create inconsistencies in your data. Obviously, it does not apply if you're behind an aggregation route, because then it's fine, like more or less. And it's an over-engineering. If you have something simple to do, you have 1 month to build up a proof of concept, please don't even try. Setting up Kafka in production takes some time, so just take Rails, take active record, build stuff, proofs, make a proof of concept, validate the business. If it works, think about it. If it doesn't, man, you save yourself a lot of time. So Kafka. How many of you heard about Kafka? Please raise your hands. Yeah, half of people. OK, so I'll just go quickly about Kafka. This is the definition, I guess, from the website. It's a distributed streaming platform, and it's a high-throughput distributed messaging system. Wow. Huh. Blah, 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 blah. This will be available later on GitHub, so I won't read it, because you can read it yourself. It's nice. It provides broadcasting. It's much easier to set it up than it was a couple of years ago. So and there's a Docker for it. So. But what is Slack? Slack is a messaging app for people, for teams. And to be honest, Kafka is just messaging app for apps. So think about Kafka as a Slack for applications, and each of you is an application for Slack. So it works exactly the same way. You send messages to channels, and you read them. Really simple. And you can send a lot of messages. And everyone is using it. We're using it. LinkedIn is using it. Yeah, Shopify is using it, yeah, with Karafka. Because it's good. Yeah. How Kafka works. Basically, you have producers and consumers. A single application can be both, which means that it can produce messages and consume messages. Sometimes you will just have applications that just consume messages, and those are the best because you don't put anything back, so you don't have to worry about anything. You just read data. Really super cool. There are connectors that are also producers and consumers that give you the functionality of just sending every single change from your database to Kafka, so you can just use this data directly. And there is something called stream processors that just transform streams of data. Kafka is about topics. Topics are channels from Slack. Simple. Each topic can have multiple partitions, and within a single partition, the order will be always maintained. So you will just append stuff at the end of the topic partition. There are consumer groups. And consumer groups are just a set of consumers sharing the same common name. And this concept is being used to load balance stuff. So Kafka will give you the warranty that a single message will be always delivered to at most one consumer within a consumer group. So there won't be a chance that a single message is being consumed from within two applications. Only one of them will receive a single message from a single topic from a single consumer group. Messages are immutable. You can set a retency offset, which means that they will be lost, and it is super important in the GDPR context, because in Europe you are forced by law, if someone asks you to remove all of their private data, I mean all of it, like you can have a certain amount of time to do that, like for example 2 weeks or a month, but you need to have this. You need to have a way to do that, and with Kafka there is no other way. You cannot just go and remove a single message from within the partition because it violates the event-driven design in general, right? Because it happened. If it happened, you cannot change it. Unless you're from some of the countries, then they try to do that. Messages are just byte-arise. So you can send whatever you want. It can be a string, JSON, Apache Avro format, or anything else you find convenient in your already existing system. It's great for scaling. The more partitions you have, the more stuff you can just process at the same time. The only requirement is that each partition needs to fit in a single server, but I've never had this problem because I have a retention time that is decent. So order. Good. Strong ordering with partition keys. That is really nice feature. Because I will talk about it in more details in Ruby context. It gives you extreme flexibility and freedom of doing in-memory computation, which means that you don't have to store data in database. You don't have to have it anywhere else than in memory in the current Ruby process. And it's completely not a problem, because if you kill the process, you'll just spin up a new one that will reconsume the stuff. It's extremely useful and extremely helpful because memory is a bit faster than the hard drives. And keys allow you to explicitly tell Kafka that Kafka needs to put all the messages with the same key on the same partition. For example, you can send all the events related to a single user interaction by using his ID as a key. Kafka will automatically pick a partition, but it will always pick the same partition for all the user data. And then a single consumer will eat it. There is no chance that a single partition data will go to this consumer, and then at some point it will switch as long as this one is running. It's great for load balancing. You don't have enough computing power, you can just spin up a next process. It takes 20 megabytes, so nothing really. It's super useful for fault tolerance. If a single process goes down, Kafka will rebalance, and the work will be distributed evenly. that is extremely useful and it's extremely helpful for testing new ideas. Because you can spin up a next consumer with a new consumer group, put it somewhere else, see how it behaves, see if it's doing what you expect it to do. If the business logic is valid, if not, shut it down, forget about it. If it is exactly as it is expected, you can just replace them one after another. You can rewind and replay services, and it saved me a couple of times because I'm not the best coder ever, so my business logic sometimes not works as expected. But this allows me to fix it. I can just go back 12 hours in history and reprocess all the data that I processed badly. I wouldn't be able to do that if I didn't have the history. And the state with Ruby. There are currently 3 libraries for working with low-level libraries like the drivers. With Ruby, it's a JRuby Kafka. For JRuby, it's Poseidon, and it's RubyKafka. JRuby is a wrapper around Kafka Java client, so you can only use it with JRuby. You want to work with CRuby stuff, and you need to read Java docs, so no, not for me. Poseidon is not maintained, but I'm mentioning about it because some people use Kafka 0.8 for some reason, and it's still working with it. But please don't use it if you're building something new. And there's RubyKafka that is maintained by Zendesk, which is really nice. I, from time to time, fix bugs in it. It happens. It's Karafka driver, which means that majority of low-level functionalities come from RubyKafka and bugs. And it provides, I guess, all you need to start working with Kafka. And on the high-level side, there's Karafka, a couple other smaller frameworks. I won't mention them because it's about Karafka. But it's a framework. And it was built to just simplify the applications development. So you don't have to worry about details, implementation details, details on how Kafka works. Don't worry, just do your business. And you don't have to know too many things about it to make it work. And it's like, I don't focus on HTTP details, how it is being parsed, what happened behind the scenes. I just take params, and it works most of the time. But I built that with my team to build applications faster, because I had 2 choices. Either introduce all of the people from within my company to Kafka, and explain them things that I explained to you now in much more details, or just provide them with a tool and tell them, yeah, just hook here your application. That's all. We wanted to process faster. And we wanted to handle multiple events and messages from many sources, and we wanted to have a standardized way. Because if you give a low-level driver to people and ask them to do something with it, you end up with having like 10 frameworks, like hello JavaScript world. Developers in a company shouldn't care about threads, signals, load balancing, connection management, and so on and so on. It shouldn't be their responsibility, but their responsibility should be providing business value. And business value, yeah, some of it is here, but majority of it is with some functionalities. We didn't go with HTTP and REST. We had a lot of microservices at the company that I used to work in 4 or 5 years ago. But we didn't have broadcasting. And if you would ask me about the most important feature of Kafka, I would say broadcasting. And broadcasting is exactly what I do with you now. I'm talking to you, and I hope you listen, at least some of you. There is no batch processing with HTTP. You send a single, or you can send like a batch of messages within a single JSON, within a single HTTP request, but for some crazy reason, almost no one does it, and no one does it for webhooks even, and I don't understand that. With Kafka, you're almost forced to think in streams and in batches, and it's extremely good and it's extremely performant. You can replace microservices, which means that if for any case, and it didn't happen to us, Ruby is not enough, take a different technology that is more sufficient for a certain task and just implement this microservice and just spin it up as a part of consumer group and then test it out if messages are being processed properly, and you can just replace one process after another within a single consumer group, and it's really good because you can have Ruby and any other technology working together alongside doing the same things, and you can just compare them on production in real time. So good, yeah. If you think about it, the world is really about messaging. I'm talking to you, but I'm not waiting for a direct feedback each time I send a sentence. And this is what we do with HTTP. We send a request, and we wait. We keep waiting. And synchronous requests are like embedded in the way we think about web programming and most of our applications. We do something, and we want an answer now. But the world doesn't work that way. It's asynchronous. And for some reason, we don't model our software that way. And some reasons are understandable. I mean, when someone opens a website, he waits, right? That's totally understandable. But why we apply the same logic to backend processing? Why when we do something, we don't do this async, which means we just delegate stuff, and yeah, the answer will come at some point, somewhere. So yeah, I built it. We've built it because I didn't build all of it on my own with things that are already there and that are really cool. As I said, with RubyKafka, with dry monitor and other things from the dry stack, this is really good. You should look at it, and super fast. We use concurrent Ruby for multi-thread internals because we have Karafka works within many threads. There's the main one, plus threads that fetch data, plus threads that process data. So despite the global interpreter lock, it's doing a couple things at the same time. At least it's doing them with I/O on sockets, and a lot of plain or Ruby objects to provide the rest of the functionalities. The framework is super simple. If you open the code, it's just straightforward. It is built from a couple components. Oh, I need to speed up. There's a router that just describes consumer groups and their details. There are consumers that actually process the incoming messages and events. There are responders for sending messages and events, and there's like CLI for management. And the lifecycle of a message or a message bus is pretty simple. They're fetched from Kafka. They go to router. Router picks a consumer. If you want to respond something with Kafka, it will pick a responder, and the message will get back. Simple, really simple, like no magic here. It just works. It's super easy to install. Just put it in your app and just install it. If it's you can just clone our example app from the repository. It works most of the time. Karafka requires a server instance, which means it requires a separate process. I know that one person from Japan actually ran it inside of the Puma process. I don't know why. I can't imagine why. But I've got a feedback that he's doing that. So congratulations to him. Don't do that. Please don't do that. There are some really nice features within the framework that make life easier. And everything is being validated, which means that if you don't know what you're doing, we probably won't let you do that. So if you decide to have a shutdown timeout with a minus value, no, it will tell you that it's a bad idea. I don't know how even it was supposed to work. I mean, should it shut down before you tell it to shut down? Anyhow, won't work, so you can just try any settings you want. If they're like really, really bad, we will tell you. But the default config is pretty stable. I mean, it works in most of the cases. If you are not doing anything sophisticated or anything special and you just want to use it, just provide an app name and a path or location where your Kafka is, or Kafka brokers if you have more of them, and you should have more of them, because one is a single point of failure. Please don't do that. Yeah, there is a routing engine that is super simple. You just tell Karafka, fetch data from this topic and consume it with this consumer. We don't do any magic routing, figuring out the consumer based on topic name, because it's not explicit. And it creates like a lot of noise, and new programmers need to look into the code base and check all the consumers to figure out on what topic we're listening and how we're responding. Instead, we're just explicit. Just do that. And if you respond with a message, just respond. So if you want to batch consume, just do it. That's the default, by the way. If you work with JSON data, or any type of data, but generally with one type of data. So for example, within your system, you have only JSON data. You just provide consumer names and topics and a consumer group. Processing is easy. Consuming, let's call it consuming. You have a params batch if you work in batch mode. And inside of a params batch, you have params with single messages. So if you use something like active record, for example, you can just directly use it and create stuff. Simple. But it's not batch processing, because usually you would just flash it all together after some validations, but you can do that. And you can also respond. This is not Rails respond with, it's Karafka respond with, but it serves a similar purpose. It will just run a responder to help you respond. The cool feature about responders is that you can set some requirements. For example, you can use its DSL to tell a responder that there always need to be reaction on a certain topic. And if you don't do that, it will cause an error. And it's really good when you design pipeline-like flows. So you take data from one topic, you work with it, and you extract it to a different topic. Because if you do something bad, Karafka will monitor this in production. There is a CLI. Most of the commands are like, server, install, blah, blah, blah. But there is one that is really interesting. There is a flow. And it will tell you on what you're listening and where should the reply go and how many times. And it's super easy if you have 20, 30 applications and you want to figure out the data flow in between them. And if you don't just consume stuff, it's super. That's the best type of apps. You won't break anything with those. The performance, 55K messages per second from a single process, more or less. Process is around, if not embedded within Rails or something like that, 20 megabytes. So it's pretty good. Less than a millisecond to send a message. You can send messages with asynchronous producer that we have as well. You can send them in batches. That makes it even much faster. And 1/10 of a millisecond if you send some statistic data and things that, that you don't care that much about. There are two important things to understand in general about the flow of messages with Karafka. It's fetching data and consuming. Fetching is the process of getting data from Kafka to your Ruby process memory. And consuming is applying your business logic into already fetched messages. You can fetch messages in batches, or you can fetch them one by one. If you fetch them in batches, if you kill this process, a different process or the same one after being spin up will reconsume all the messages, which means that you have to deal with reentrancy and stuff like that, but you always should, so no problem. But if you're paranoid, you can always consume message by message, but it will make things small. I know, 5 minutes. Yeah. So batch messages, batch consuming. yeah, you can just import all the things, extract them from the params, flash them into database. On duplicate key update, much faster, much better. But if you're moving from a world of normal requests, you can always make sure that you can process them one by one. One nice feature, next feature is the params lazy evaluation, which means that your messages aren't being parsed until you use them. And it's super useful because you can reject messages based on metadata. So you can use this feature to reject messages that are older, for example, than 30 seconds. You can implement buffers because consumers are persistent, so you can flash data every 1,000 messages or something. And it's super for in-memory computation and flashing only the results. Yeah, they're persistent, great for sagas, super. Yeah, it needs to speed up. Multi-batch transactions, they are great for and manual offset management. It's like committing the moment you are within a topic partition. They're great for sagas because you can wait for all the events from all the topics and only then perform your logic. Yeah, Drive monitors for validation, which is super, super nice because you can subscribe some simple listeners. But for production, you can subscribe totally different instrumentation than you do for testing, which is really, really nice because you shouldn't report that stuff for testing. You can deploy it wherever you want. It works on Heroku, Capistrano, yeah, Docker, everywhere. You can integrate it with Heroku, for example, or any other provider. It provides topic mapping because some of the providers like Heroku require you to have a topic prefix with your name before the topic. So it means that your name leaks into the business, which sucks, because if you decide to change provider, you have to rename parts of your code. So you can have just mappers, and it's good. Yeah. You can integrate it with Rails, works. With any other web framework, works. It's simple. It's described in the wiki. You can use it with all of this, Reform, Trailblazer, ROM. I use it with it. Simple. Yeah. One thing that I wanted to talk also, but I don't have enough time, so I'll just skip to. It's a proof of concept. No, not proof of concept. Example how we do this. Castle protects your systems from account mitigation, which means that even if users' data gets leaked, which means login and passwords, we detect stuff like that, and we protect users from that happening. And there are a lot of leaks like that every year. But what can be faked is user behavior, because you can track how users interact with your software. You can build up models on what they do, and this is what we actually do. And even if someone has a valid credentials, which is login and password, they're able to authenticate, we're able to detect that on the other side of the computer, there is someone else than someone that should be. And we track a lot of data, like everything, all the time when users click. So we detect and score things that are suspicious. So we're able to figure out that someone is trying to hack the account. We have 100 million events per day, 25 million active users daily. And we do this in Ruby. 50 million active users overall, and 2.5 million failed logins or successful logins, but blocked by our system. And I have 40 more seconds. So we put everything into Kafka, like literally everything. When users click, how they move their mouse, what they do. So we are able to build some models of their behaviors. We do this in real time. And we use Kafka also for real-time data backups and archiving. So we have topics, and we have separate consumers that do different things with the same data. Some of them are just backing up the data. Some of them are applying business logic. And it's all being consumed by Ruby. I know, 4 more seconds, yeah. Thank you.